And thank you everyone for joining us in this webinar today. My name is Haider Khan, and I am the Product Solutions Manager for Huawei Solar Business in Australia. We'll be going through the Huawei FusionSolar Residential Smart PV Solution, AI boost for optimal electricity cost and active safety. So Huawei inverters, as you guys will be fully aware of, for the past 5 years, we have been ranked #1 in terms of global inverter shipments. So it's a good success story that I normally do tell, that power conversion equipment, inverters, were manufactured by Huawei for the past 20 odd years or so as an accessory for the core business in the ICT. And from an accessory to a business unit in 2013-ish, and to the #1 global inverter shipment supplier. Not only that, a trendsetter. So if you're on the left, you can see the blue ones are the share of the string solution. So we changed the market from central focus to string focus. So that's the story, that's the strength of our R&D as well. What I'm going to present here is the residential solution. So we operate in all the three sectors. We started off from utility scale solar farms, then scaled down to CNI, commercial industrial solutions, and then residential. So what I'm going to discuss today is our residential solution. So when we came up with our residential solution, key points were that with all the reliability and all the technological advancements of the utility scale and the ICT background, what we focused was on that one inverter, one box should fit all scenarios, tick all boxes. So we came up with the residential inverter, the first gen. Now we have moved on to the second gen inverter, which is single phase we call Sun 2000 L1 series. So we have 2, 3, 4, 4.6, 5, and a soon to be released 6 kilowatt single phase solution. So this box, this inverter here, can be used as a standard grid connected inverter with our power sensor for consumption monitoring. This same inverter, no other product line, can be used for a fully optimized scenario as well as a no optimizer solution. So you can either use it as a base case with no optimizers, or you can use a full optimized solution and get panel level monitoring and the other associated benefits associated with full optimized solutions. You can also hook up a battery directly into this particular unit. So it's not a different model of an inverter, same grid connected inverter, which is truly hybrid in the sense that it can directly connect to a battery without any additional interface. Which battery it is compatible with? Single phase LG Chem high voltage, as well as soon to be released later this year, Huawei's battery, and the 3-phase connects to the Huawei battery. We have our second gen optimizers, Sun 2000 450 watt P. Then we have different connectivity options as well, W and FE dongle. So you can hardwire using the FE port on the W and FE dongle to the router. You can use the inbuilt Wi-Fi of the inverter itself to connect to the router, or you can use a 4G dongle and don't rely on the end user's home router for internet connectivity to the portal. Then our white labeled smart power sensor, single phase and 3-phase, they come with 250 MCTs and the monitoring portal and cloud. So what are the 8 prominent features of Huawei solution? So we broadly divide them into 3 categories: safety, yields, and experience. So this is a classic web graph over here on your screen. The blue one shows the Huawei solution where we stand. The gray one shows other optimizer solutions where they stand among these features, and the red one is other inverter solutions. So number one, AI-powered active arcing protection. So active arcing protection, Outfault circuit interrupter. What is this? We will be discussing it a bit more in the further slides. This is not a regular Outfault circuit interrupter, it's AI powered with near to none noise and stripping. Pinpoint arc fault positioning. Once you got an arc fault, you can also pinpoint arc fault positioning where the arc fault is. Saves a lot of times of troubleshooting. 0-volt module level shutdown. So this is, if you look into the gray curve, this matches Huawei as well because this is a standard feature with optimized solutions. And up to 30% more energy by optimizers. Again, a standard feature by optimizers for optimizer solutions. 2 times power battery ready. Again, Huawei and other optimizer solutions have this as nearly a standard feature. One fits all optimizer. Now this is where we are different, that one optimizer is suitable for 60 cell panels, 72 cell panels, landscape layout, portrait layout, so eases out the stock management. Less than 5-second module auto mapping. So those who are installing optimizers and do physical layouts, they know this is the most painful process. And with AI powering this for our solution, this takes less than 5 seconds in mapping the physical layout. No quick wear parts. This is across our complete range, whether utility, CNI, or residential. No quick wear parts, no fans, no screens, no buttons, and no string fuses as well. So we will discuss active safety first. So electric arcing. So when it comes to DC, electric arcing is what is to be considered. In Australia alone, in the past 10 years, since 2010, there has been more than 400 cases of rooftop fires. Well, that also comes down to we have a very outdated regulation of having rooftop isolators installed on the roof. So loose connections there, damages on the rooftop isolators, that is a big cause of that failure. But yeah, so if there is a mechanism that can detect arc faults on the roof and disconnect it and safeguard, that is a preferred way to work. There's an American standard US 1699B that specifies arc fault requirements, circuit interruption requirements. Like, first of all, let's see what is an arc fault. It's an electrical breakdown of air that produces a prolonged electrical discharge. And why is an arc fault there? What causes an arc fault? Arc fault can be because of unreliable soldered joints, broken PV cables, or loosened PV connectors. And what is the harm? The temperature can reach up to 3000 degrees and can start a fire. Okay, so what if we bring this arc fault circuit detection in the inverter itself? So without any additional device, can the inverter detect arc faults? Yes, it can. But what are the challenges? Arc faults are AC noise signals over the DC signal. The challenge is this noise signal is generally weak. Sometimes long cable run can also weaken it, and this might get undetected. The other challenge is that other interferences due to the load, grid, or the inverter itself can be on the DC cable and seen as an arc fault because that's an also AC noise signal. That misreading, false detection leads to nuisance stripping. This is why Some other inverter manufacturers, they claim they have AFCI, but it is disabled by default because they don't want the installers to go on site calling the service team every now and then for this noise and stripping. So it's good to have it, but disabled by default. Is it useful? No. On the left here, AFCI disabled by default. The arc still persists and there is a fire hazard. On the right, AI boosted Huawei solution enabled by default. That's the confidence that we have in the algorithm, and it distinguishes the arc within 400 milliseconds. So how do we work around it? Why do we call it AI boost? I'm just going to share this video here. Okay, so we have an AI algorithm which is a 99.9% accurate, and in that algorithm we have this self-learning of the inverter, neural network algorithm self-learning of the inverter, which compares arc faults spectrum with the signal that has been detected. Is it an arc fault spectrum? Does that spectrum match the arc fault, or does that spectrum matches a noise interference? It confirms the spectrum as an arc fault, and this connects within 2.5 seconds is a requirement stated by US 1699B. And if you have optimizers, fully optimized solution, then it will pinpoint the arc fault as well. So pinpointing the arc fault for a 10 kilowatt array, you've got an arc fault for 10 kilowatt array. If you go on the roof to see broken cables, to see if there are any signs of burns, are there any signs of unreliable soldered joints, it might take up to 5 hours for 10 kilowatt array. With full optimized solution, you can pinpoint where the arc fault is, and it saves 80% of your time. You know which panel to look for. 0 volt module level shutdown. So this, someone has to go on the roof for some maintenance work, repair work. Then you have to get the voltage on the roof down to 0. This can be done through optimizers, and you just switch off the inverter, put the AC, switch the AC off, and the voltage will go down out of the panels to 0 volts. The other feature here is all the optimizers have 1 kilo ohms of impedance, so you can verify the correct installation of the optimizers before pulling them down to the inverter. Higher yields, so up to 30% more energy by optimizing each module's performance. So panels are connected in a string, series, one panel shaded, or different azimuth, or whatever. It drags down the output of all the other panels. If you have them optimized, only that panel is affected. Give you higher yields. Now, this is an example from a real plant in Germany. And here you can see the physical layout matching the roof layout here. The panels that are shaded, only those are being affected. The other panels are not being dragged down as a standard sink solution will do. Higher efficiency, we talk about yields, higher efficiency, compare efficiencies of these models. You'll find Huawei efficiency being higher. Now, this is a very interesting case study because this is our colleague's house here in Australia, Sydney. And he installed a 10 kilowatt system, two 5 kilowatt inverters, one Huawei and one another European brand. And they used identical string sizing, identical strings into those inverters, and he just compared the yields out of it. So 4.5% more yields from the Huawei, and a true battery-ready solution. This is a standard grid-connected inverter, Huawei here. If you want to add a battery later on, it's direct plug and play. Whereas if you use another standard grid-connected inverter, you want to add a battery on, you have to install a storage interface, or you have to go for an AC coupled solution. So digital turbo, the chipset that we use for communications between the optimizers has improved the experience of installing optimizers, which we will see in the further slides. A one-fits-all optimizer. So this basically simplifies stock management, PO management, spare and service part management. One optimizer can fit to 60 cells, 72 cell panels, and can be used with the portrait or landscape orientations because it is provided with a 1.2 meter cable output. The second gen optimizer has a much smaller size, 50% less than the competitors. You can opt for a long string design as well. So this saves a lot of balance of system cost, a lot of cabling cost, and can increase the yields. If you're using a full optimized solution, then your input is not restricted by the input voltage of the inverter itself, but it is restricted by the input power because the voltage, the optimizers operate in buck mode. So you can go up to 2 times oversizing of the inverters. So here, for example, bottom figure here, you can see that this 10 KTL M1 inverter can connect 28 panels in one string in a long string design and 28 on the other. Here you can see the data sheet, maximum power. So 2 to 5 KTL L1, 5 kilowatt per strings. For a full optimized solution, it can go up to 10 kilowatt. Screwless installation, so eases your installation on site for the AC connection, so you don't have to uncover the inverter, you don't have to manually tighten the AC wires. And the high silicon chipset I was mentioning, that it gives you much reliable data transmission even if it is blocked by noises. So with this, less than 1.5 minutes of pairing up of a 10 kilowatt array. So if any of you guys had installed a previous version, then you can say this is a significant improvement just because of the high silicon chipset and the power line communication technology that we have used. And less than 5-second auto mapping. Here I will have to go to the video again. So if you use other solutions for optimizers, the most painful part is when is you have to do the physical layout. So with our solution, you paste the QR code as per the orientation on this paper, and during commissioning, you just take a photo of this paper, and it translates into the physical layout. So this physical layout creation is less than 5 seconds, just AI powered, taking a photo and then transferring it to the layout. Whereas the other solutions, you have to manually do the physical layout, which is the most time consuming part of hooking up optimizers. There you go. You can see all the optimizers. And better experience, no quick wear parts. So this comes from our expertise in utility scale solar farm, that we have a reliable solution. Our failure rate is less than 0.5%, and TUV has certified it to be less than 0.39% in a 700 megawatt plant. Why? Because we don't have much wearable parts. So we don't have LCD screens, we don't have buttons, we don't have fans, and we don't need string fuses. So the availability is much high. No fans, and we still achieve a 50 degrees D rating. So this is through our 30 plus years of telecom products national cooling experience. And this is how we design the heat sink. It all comes down to how we design the heat sink and where we place the electronics for the thermal design. 2-in-1 internet connectivity option. So you have a WLAN FE dongle. You can use the Wi-Fi of the inverter, inbuilt Wi-Fi of the inverter itself, if you're talking about the single phase L1 inverter, or you can use the FE port of the WLAN FE dongle to hardwire to the router. It's also compatible with the 4G dongles. So 4G dongles comes very handy when we talk about power purchase agreements or social housings, where you don't have to rely on the end user's internet connection for connectivity to the portal. So it comes very handy. And then again, I'll jump to the video. Connect to FusionSolar, and this is a bit of an intro of FusionSolar App. So with the app, you have real-time reporting, so you know how much you are producing. You can use this app, or you can use the app, or you can go to the web portal as well. Module level layout, module level management, physical layout as well. You know which panel is producing how much, and then you can look into the energy balance as well. How much you are producing, how much you are exporting. You can go for the day, for the month, for the year. It's all on intl.fusionsolar.huawei.com. Okay, so the product itself. 234 4.65 KTL L1, 6 KTL L1 coming soon. 2 MPPTs, 2 strings, so 1 string per MPPT. Local commissioning is the built-in WLAN, and then we have options for WLAN FE dongle, a smart dongle for 4G. AFCI is becoming a standard feature in the new models, and compatible optimizer 450 watt P. 3-phase 5.6 KTL M0 that we have at this stage, which will be upgraded to M1. Local commissioning with the wireless LAN, Communication to the router. Standard is to the WLAN-FE dongle, which is provided in the box with the 3-phase models. And you have an option for the 4G dongle as well. The difference between M0 and M1 will be compatibility with the optimizers. Then the 72450 watt P optimizer, DC M-bus communication to the inverter, no gateways required, communication over the power line, maximum power harvesting from each module. That's what optimizers do. Module level monitoring, open circuit impedance 1 kilo ohms for installation and verification, and rapid shutdown. Then we have these white label smart power sensors, which are provided with the 250 amp CTs. WLAN-FE dongle can connect up to 10 devices, so you can master slave them and connect this to the master inverter. WLAN smart dongle 4G, again, can connect up to 10 devices. Then the energy storage. So the Huawei Luna battery, which is due to release end of 2020, 5 kilowatt hour modular, and you can connect up to 30 kilowatt hour of storage. Peak power output 7 kilowatt for 10 seconds, and the chemistry is lithium iron phosphate. FusionSolar App and management system. And quickly just show the scenarios that these solutions can be used. So this single-phase residential can be either used as a standard grid-connected inverter with consumption monitoring. It connects to the homeowner's router using the inbuilt Wi-Fi and has short-range Wi-Fi for local commissioning. It can be used as a full optimized scenario without any additional devices. And without any additional devices, you can directly plug and play batteries. The battery compatible with L1 is single phase L1 is LG Chem high voltage R, or the Huawei battery that is due end of this year. And if the grid is unstable and you need some backup supply, you can hook up this backup box and wire essential loads to the backup box. 3-phase scenario. Same base scenario where you are using this as a standard grid connected inverter with consumption monitoring. You have the WLAN-FE dongle to connect to the router via WLAN or FE. You can use this inverter as a fully optimized solution as well without any additional devices. M0 and M1, the difference between M0, 5-6 KTL M0 and M1 is that M0 cannot communicate with optimizers, M1 can. Then no additional devices, you can plug and play Huawei battery. So 3-phase solution only compatible with Huawei battery. Again, backup load required. Then you can wire essential loads, single phase essential loads to the backup box. Okay, so that's all from my side.